Well, hi, and thanks for joining me here in my shop today. I'm going to be carrying on with this radio. We're going to do a number of tests, including some rough alignment work, and see what we can get out of this radio at this point. But first, I've made a little change in my work flow, and I'll explain why, because it may have an impact on the video. Some of you have been watching my videos for years and years. So my normal pattern is eat my breakfast, come in here, work away on the radio, maybe work an hour and a half, a couple hours. In there I gather about an hour and 20 minutes worth of video, something like that. It just works out that way. I don't really plan these durations, it just works out that way. Put the video together, get about an hour long video. By then it's around lunchtime, sometimes it's 2 in the afternoon, occasionally it's even after dinner, and I'm doing the putting the video together. Just depends how my day is gone. The more complicated the work in the shop, the more complicated the video is to make. Typically for an hour's work in the shop, there's about a half hour of video work, roughly, something like that. Maybe not quite that much. Sometimes though, actually, there's more work in the video than there is in the shop work. So I try to avoid those things too. So the change in my practice now, or my workflow, is I'm going to come in the shop like I've done this morning. I'm going to assemble the video from yesterday's work. That will make me look over everything I did yesterday. And then that video will be ready for posting sometime this morning. Then after getting the video ready, I'll turn my attention. You can see from the clock on the wall now it's about 10 o'clock. Usually I'm starting about 8 o'clock in here, 8 or 9. It's 10 o'clock, I'll start working on the radio, and what's in my head now is a refresh of what I did yesterday, because frankly all it takes is overnight sleep, and a good deal of stuff is not in my head in the morning that might have been in there the day before after doing this work. So a good example of that is I poked around here with my ohm meter and got this bizarre 560 ohm reading. Couldn't seem to sort out why that was. I can't imagine why that was. And then I moved on. So having just done the video, I've reminded myself, oh yeah, what happened to that 500K thing? 500 ohm thing. So B minus to the chassis. There's no 500 ohms there. I'm on the 20,000 ohm scale. And then if we go, this is just another chassis point, here's another point, 0. Okay, so that's, I'm connecting B minus to B minus at this point, that's why we're getting a 0. So whatever that 500 ohm, 560 ohm thing was, goodness knows, it's gone now. I don't know. that's the bottom line. I don't know. No, this has been out of the radio for a long time now. I have a lot of capacitors to test. And hey, why don't we do that right now? Let's test all the capacitors that have come out of this radio. And then we'll, next thing we'll be doing is checking voltages on each of the tubes. Make sure plate screen voltages are there and they're in the ballpark. And then after that, it's a rough alignment. And at that point, we'll kind of know what this radio's performance is for the first time. It could still have more problems in it. I'll bet you it doesn't though. So what are we doing next? We're doing the capacitors next. We'll just swing that camera over here, Jim. Let's go at it. So first one we're going to try is this big electrolytic one here. Now, I don't test electrolytic capacitors to any great degree with this guy. So my experience is low. Polarity is important here. I put the positive, pick the red dot, positive one there. Now to test an electrolytic capacitor, because electrolytic capacitors have compared to a regular capacitor or a non-electrolytic capacitor, they have a lot of leakage. So there's a switch on this device that you switch it, and now it's more calibrated for telling you the quality of an electrolytic capacitor. It has a power factor adjustment here. I seldom have made use of it. I'm just going to leave it at 0. I won't talk anymore about it for now. So I'm going to put 50 volts onto this capacitor. It's going to take a while to charge up, so the eye will close during the charging process, and then once it's charged up, the eye will open maybe. Here we go. That was pretty quick. So it opened right up. 50 volts. How about this? So, you know, this capacitor is not testing bad. Just for interest's sake, if I did the test with the regular capacitor setting, boom, it's going to show a short or a leak. There we are, 150. You can go even higher. Go to 250. It hasn't opened all the way now, but whether this is really a bad capacitor or not, I just can't tell you. Let's go on the other side of it. We'll go right with the same voltage and everything right now. Just compare. Very similar on the other side. Actually, I think it opened up just a little less on there. Okay, a little hard for you to see in the camera. You can see just enough. So we're going to put this here. Now, how about those last 4 capacitors, which whoa! Yeah, that was almost the camera heading for the floor. Let's take a look at what's going on here. So I numbered these capacitors. We'll pick number 1 is the one that was kind of grounding the antenna system to the B minus. Number one. Here's number 1. Should probably just test these, and if one of them comes out really sick, then look and see where it is. There's all kinds of ways to make this more interesting than not. 50 volts. Good show, Jim. You remembered to throw the switch. 50 volts. Not quite open all the way. 150. Not going to open. Very, very typical. So, I mean, not an end of the world situation. I think they're all going to test like this. Let me get number 2 here. Here's number 2. So number 2 is this one, which is so this is the drain the chassis back to the B minus capacitor. Volts. Open right up. 150. So this one is showing a much better performance than the last one. 150 partially open. But of course, you know, they've all degraded. Who's next? The next one we will pick is number 4. Number 4 was this one. Number 4 is the one that's pulling the bottom of this coil on the output of this tube, pulling it down to B minus from a signal point of view, avoiding this resistor here. It's actually, that's actually B plus coming in this way. Okay, so if this one's not working, then we don't properly ground this coil, and I'm sure that would greatly weaken the radio. Now, not working, what does that mean? So, you know, there's 2 things here, right? There's the block the DC, don't have a leak side of the capacitor, and the other one is the capacitance itself. And would you believe at this point in my electronics lifelong electronics career here, I read a paper on capacitors that just about blew my head off, basically indicating that everything I thought about how they worked is wrong. And I have the standard stuff in my head, same stuff you have. Isn't that something, how you can get this far with a belief and then find out that, you know what, it could just be a model, there's something deeper going on that is worth understanding with a capacitor. And what we can understand with this one is this is a sick puppy. 50 volts and the eye won't open. Okay, last of the numbered capacitors. So these are all the RF type capacitors, if I dare to call them that. I think that's a fair category for them, as opposed to audio capacitors. This guy, which number was he? He's the last one. Number 2, 3. Number 3. Number 3 is that one. Number 3 is the one that was that I left out of the radio briefly, and its job is to drain out any charges or voltages or pressures, signals, whatever you want to call it, that might be forming in the shells of these two tubes. Drain it back to the B minus, bond it to the B minus, so there's no difference in potential between the B minus, the chassis, and the shell of those. I just totally lost track of what I'm up to. Here we go. Never mind that sentence. And again, it's just a little bit of leak visible there, and of course it's not going to open on that. So all tired old capacitors, all the same kind of condition. Now these ones have just come out of the audio circuits. I don't know which is which. I'm not going to bother trying to sort it out. We're just going to go through them quickly. That guy's working good. Look at that. Go higher. It's at 250 volts already, and this one's working good. This is the 0.005 capacitor. I think that might be on the on the volume control here. So off the slider. So he's not doing much in terms of holding back DC, but for some reason he's come through. He's come through good. You could have stayed in the radio for a bit longer, but you're out now. You're out and you're gone. 50 volts on this one. Opens right up. 150, not opening right up. Okay. Now this is the TCC mystery capacitor. Mystery to me anyway, maybe not to you. This is the one that just, I think it's probably looks so different from the others simply because it's a different manufacturer and there's differences in the wax or something like that. There we go. Open up. Oh, I thought it was going to open at 150, but nope. If you're doubting that if I put a new capacitor in here and do this test, that I can get it all the way up to the top voltage, 450 volts, and the eye will pop right open on a brand new capacitor. Okay, 50 volts. Not bad. Not making it past the 150. So they're all testing kind of similar conditions. Now we got one more paper one. One more paper one. Just in case you're wondering why am I rolling it and doing stuff like that, I'm trying to make sure that there's contact here with the clip leads, that's all. 50 volts. Beauty. Not so good again. You could kind of sort all these out, in quality based on this test. Relative quality. Now we're getting into an interesting one here. This is the Sangamo Type 33.01 600 volt guy. Yeah. Don't buy those lousy wax ones when you can buy this fantastic plastic shelled version of it. Why depend on beeswax when you can depend on whatever the material that is? Plastic. And here we go. Right open. Right open. Not quite open. We're going up to 350 volters on here. Still opening at 350 volts. Okay, so this has got, I gotta leave this on for just a moment. We charged it up to 350 volts, take it off right away. A good portion of that's still going to be there. In this testing device, when you let go of this spring-loaded control, it snaps back to normal. They could put the word short on there because it's applying a short on the capacitor. So for sure this is discharged now. It's probably discharged in a moment. And now we are left with this electrolytic 100 microfarad 25 volt one. I'm going to put 50 volts on it. That's the lowest I can put here. In fact, let's not make a mistake. So it's going to have to stand up to 50. Will it stand up? Again, electrolytic, I'm not so familiar with it. Ready on the eye. Like it's not even open. Oh, it's opening slowly now. It's a big capacitor. Give it time. Give it time to charge. That's as far as it's going to go. What if I fool with this control here? No, it's not going to do anything. I don't think this is effective anyway. So, if rotating this control is not effective during the voltage test. Now let's measure the capacitance of this. I'm going to give it a little bit of time to discharge. Should be pretty quick actually. And we're going to go to, this is 100. So 20 to 1,000. Let's see if it pops open here. Here. Pretty clear, it's right in this area. Okay, let's read it. On the 20 to 1,000 is right on the inside here. 1,000, 500, 200, 150, 100 is right there. So it's 100. So I think this was still a good capacitor. Whether it was doing the radio any good, we're still not sure of that. Okay, I took this out. The radio's output is low now. Volume output is low. Now that I have another capacitor to test. Here, let's just convince you here. I'm going to get a brand new one. Is Jim being honest? Is his machine honest? Does it tell the truth? 50, right open. 150, right open. 250, right open. 350, right open. 450, right open. You may want to grab onto that now. The basic rule with discharging a charged capacitor is if you charge it for 2 minutes, you should short it for 2 minutes. That's the basic rule. I don't think you really need 2 minutes of discharging on this. I'm sure it's already done. Good. So there you are. Proof to you, proof to me too. Because once in a while I do like to do the reality check here. Make sure what I think is true is true. That's kind of one of the things we do in life all the time, isn't it? So where are we at now? Now it's time to fool with the radio. We're going to find out if it's got nice voltages in it. It's pretty simple on this radio because there's no transformer. The B plus is going to be around 120, 130, something like that. And we should find something like that on every one of these tubes for the plate. And a couple of these tubes have screens in them. They also are supplied with high voltage, so we should spot that too. We will poke around with my indicating meter here, which I will attempt to make a little more visible. Okay, just leave the radio invisible. Oh, such lighting problems. Let's move this over here. Let's move this over here. Now, I could take the time to look in the schematic and figure out we'll leave it like that. Which terminal is which on these tubes, but I'm not going to do that. It doesn't matter about a signal on the antenna. In fact, we really don't want to hear this, other than to know it's working. Doesn't really matter where it's tuned. I think one thing that matters is that it actually be plugged in. Let's get this out of here. Okay, back down here so you can see the meter. That looks good, except for this light. We're good. Probe set to DC, 150 volts on the meter. We're plugged in. Speaker is connected. Good. Here we go. Boomba. Okay, always starting up with the dim bulbs in these situations, just to be sure. And then if the voltage here gets up within the normal range, which it is already, 116, then that's fine. I'll just leave the dim bulbs in because it's just a little extra protection for me. So let me look and see. Well, let's not look and see. Let's listen. That's 1.6 sounding radio. Boy, oh boy. I was doing this yesterday when I had it upside down. Oh my gosh. Okay, the fact is that that is really a bad indication. I thought all that craziness would go away when I put in the capacitor. Oh yeah, there's a lot of craziness in this radio still. So let's check some voltages anyway. We can get through that stage regardless of the craziness that might be in here. We'll just start down at this end. And this tube is the, I can't see it here in the dark. This tube, yeah, tube diagram. Just a second here. Let's just take a look. Don't guess. Okay, in line with the IF cans in the corner by itself. And it's the, so that's the SK, that's actually an SJ. So that's a very front end tube. Okay. Bump my meter a little bit, bump my camera a little bit. So on this tube, I gotta look here, there is a screen. So we should find high voltage on 2 pins in here. We'll start with pin 1. No. Pin 2. Pin 3. See, I got my fingers on the chassis. I'm well aware that I've got my fingers posted on the chassis here. So just in case you're a safety-oriented person. So here we go. Here's one. It's got this red wire on it. And reading that meter, 150 volt scale. It's not much there. So on the 150 volt scale, it's 60 volts. Okay, let's get going, because maybe that's a screen. Here's another one, 60 volts again. So plate and screen. That was plate and screen. Wow, that's not very good. 60 volts. That's not going to help out much. Really, I don't think that's quite right. Let's try, what is the B plus in this radio anyway? I can pick it up off this capacitor here. That's what's available, 130. Out of 130 volts, 60 making it up here. Let's keep going. So this tube is the 12BE6 tube. And the 12BE6, that's a busy tube, isn't it? 12BE6. Did I not write the tube number in here? That's strange. They don't have the tube title written, but that is a 12BE6, so triode and a couple of diodes. It's not really all that busy. So we should find only one high voltage terminal in this tube. There's one. 70 volts, slightly higher than the other. Another one. Wait a minute. So probably either side of the I'm not going to say it. I don't know why we got 2 there. In here. Why we got 2 there? 12BE6. Am I stupid about that? 12BE6. So a BE6 is a very common, more modern tube. It's a miniature tube. It's kind of funny to find one in here, and all the rest are the older vintage. BE6. Come on, just think for a minute. Pentagrid converter. Pentagrid. Oh, what am I doing wrong here? Something terribly wrong. So that's a SK7. It's just a 12BE6. Wow, what a stupid person I can be. I can be pretty stupid at times. It comes in waves. Okay, 12BE6 here. And look at all, now, yeah, busy tube, all right, yes. And it's going to have two high voltage terminals on it, which it does. But they're not very high. 60, doesn't sound right. Does not sound right to me. In fact, got the manual open. What does the manual suggest for a plate voltage? It suggests, don't put your fingers on the radio there. The maximum ratings. The plate voltage 300 max. And then typical operation, the plate is running at 100 or 250. Those are the two operating points they describe in there. So, 100, but instead we got 60. That just sounds way low. Let's try this tube. This one. This is the IF amplifier. It's a SK12 SK7, isn't it? And that would have two. Yeah. Just all those grids in there. Two of them are on voltage. Two of them have voltage. 2. Okay, finger on the chassis again. This guy here. 60 again. Everybody's got a low plate voltage. There's the other one, 65. Plate and screen voltage is low everywhere, but not low in the power supply. Let's keep going here. One more tube. Now this is the detector tube here. Am I not right? Am I not right? So we'd only find one high voltage on the detector tube. Start here. There it is. Finger on the chassis, and that's only 40. 45 volts. Good thing I did this test. Well, the last one's got this on it. No voltage there. 40. Wow, this is pretty sad. Now we'll look at the output tube. The output tube often gets its plate voltage derived from a different point in the power supply, a hummier point than the B plus that's used in the rest of the radio. So maybe it's got a full voltage because it's not got the problem, the supposed problem that the others had. Now this guy has a screen, but on the diagram here they show it as two funny looking little brackety plates. That's because it's a beam power tube. The beaming of the control of the electron river, if you want to call it that, that's a bad thing to call it, results in better something in the tube. So okay, we're going here. Still touching the chassis now. I got both hands going. Put one back in my pocket. Nothing there. That's an open terminal. Nothing there. This will have it, I bet. Wow, there it is, 125 volts. So you see the whole shebang is making it here. It's not making it anywhere else. And I should keep going around, but it's kind of difficult. You should find another high voltage. That's a non-terminal, maybe this one. No, that's the one I started with. Did I find only one? This is definitely the, yeah. Let's go around again because it's very important that both voltages be present. So we'll start here. Oh, okay, so that's 65. 70, and there's the full plate, 125. So right next to it is the screen. Now typically you operate the screen at a lower voltage than the plate, but not always. So I'm a little confused about that. Never operated higher. Apparently would be the rule, or the screen becomes your plate. The screen is in there to change the inter-electrode capacitance, to reduce it way down. So the capacitive connection between the grid and the plate is far, far, far less. The early problem, or a problem with the earlier tubes, was there was quite a capacitance between the plate and the grid, and that operates like a capacitor and feed the plate circuit right back onto the grid, right inside the tube, causing it to, as they would phrase it as, it would cause instability in the tube. Makes it oscillate. So we got very high and then very low. Yeah, we're going to look at the power. Let's look on the computer here. So we're going to take a look at the power supply and find out if what I said was true. Now the way that they've drawn this is just a little bit tricky to look at. But if we say this is where the plate on the output tube is getting its juice, basically on this wire, not connected there, it's coming out of the other side of this big resistor. Why does this not look right to me? So this is actually the higher voltage lead right here. This 2700 ohm resistor is not what I thought it was. This is the screen resistor. I think you could call it that. No, you can't. Here's the screen. Oh, the way they've drawn this is just confusing to me. So we just look at the B plus arrangement here. Let's see. You would... What exactly is going on here? You kind of go up through there, back down, through here, to get to here. This is all. This is B plus down here. B plus. So this would be the second side of the power supply. I wish they'd drawn this differently, because I'm really. Hey, what about this 18 ohm one here too? That's kind of a. So if this were gone high and it's dropping the voltage in the power supply, we'd see it dropped here too, but it's not. It's all here. It's all on these capacitors, at least one of them. I only tested one of these two capacitors. You know, this resistor is not intimately connected to this capacitor. I keep looking at these wires going by and thinking it is, but it's not. It's connected to this one. So, you know, what I'm looking for is a pi arrangement where you have the two capacitors and between them is a resistor, a high wattage resistor, like that. So I'm trying to make this fit my head on this. Now, is this, like, why did they do this up here? Is it a wild chance that this is a filtering action? Instead of using a field coil on the speaker, they just, I don't know. Can you do that kind of thing? Right in the transformer that's driving the speaker? Okay, so this is just not clearing up in my head here. It's just not coming clear. Keep working at it. So B minus is this line. B plus is this line. Clearly this capacitor is between it. This capacitor. So if you just eliminated this connection here, which you can't, but let you eliminate this, then you would hook this wire right over here. And then you would have a capacitor, and with the wire hooked here, you'd have a resistor, to the other capacitor. So that would do it. Ignoring the fact that this is fed up through here and down again, it would look like this resistor is what I thought it was. It's the pi resistor and the pi filter. I mean, it's the right size. So the concept here is this guy has gone high. He's now 35 or 4,000 ohms. And the voltage on the far side, which is here, has gone low. And this is the voltage that's feeding everything else in the radio. So I'm just trying to constrain or push this, you know, my view of this schematic to fit my experience with these things. I think we got to find the 2700. Should be easy to find and measure it and find out it's high. That's our first step. I'm trying to determine why there's low B plus out here. Okay. So I apologize for taking so long to kind of sort that out, but you know, that's what happens, and I'm sure if you're doing this kind of work, it happens to you too. And it's so easy to make a mistake and then run forward with a mistake for quite a distance. It's worthwhile sometimes to spend a lot of time making sure you're not making a mistake, like putting your fingers into a radio that's still got the power on. That would be a mistake. Now, the big honking resistor. Well, I see one right up here right away. The big honker right in there. And that is a 2700 resistor right there. And it looks beautiful. It just looks, it looks like a happy resistor in there. It's never been hot. It's comfortable. I think I even see a smile on its face if I look close enough. Well, smile or not, we're going to check it. 2700 should be on this scale. And we're checking it in circuit. If we get a funny reading, if we get 2700, I'll be satisfied. If we get anything else, I'm going to have to investigate the reading itself. Well, that's one lead. The other lead is right in. Where's the other lead? Oh my God. The other lead is disappearing. It's disappeared behind all this stuff. I got this weird schematic to look at. Oh my gosh. So, I mean, to get from this resistor up to this coil, there's going to be a wire lead coming back to a terminal to pick up, to make the connection. So one side of this is going to connect to a wire that goes up. That's probably the side I can't see. So we'll go up through here, and I think it's all dead ends, DC wise, everywhere. But maybe I can read it. Well, we can just figure out where to. That's right. The main problem is, what do you do with your lead here? So one end is right onto a tube. Oh boy, this is gain. This is output tube. This is tricky stuff to try to spot. Right here. So one end actually makes a connection right to pin 4. So is that, and that's the visible one, unfortunately. The other one hooks up to a wire on a terminal somewhere buried under there. Buried under all those capacitors. Come on, come on. So if I'm going to read it, I'm going to have to read it. Oh, the other side of this transformer, I could get that on pin 8 of the, is that pin 8 or is that pin 3? Pin 8 of the 35Z5. So find pin 8 of the 35Z5, and I think we're going to read more or less. Yeah, more or less. So pin 8's right here. Pin 8. So we're looking for 2700. $170. Wow, okay. I did say if we get something really weird, then we'll have to investigate the test. So with this side of the resistor is really just, well, you know what it comes down, well, there's a capacitor there. what I'm thinking about is put my ohmmeter on here. The ohmmeter test current can find its way through all kinds of stuff potentially and throw this whole reading right off. And I think that's the case. I'm not going to be able to trace all this back through here. Typically resistors go high, they don't go low. The low there would raise the B plus in the radio. So far we are left with no explanation for it, the low B plus. Why don't I check the other side of that resistor? I'll turn the set on and we'll read the voltage rate. The output side of this resistor is pin 4, so we can read. Oh, pin 4 is already low. Pin 4 wasn't low. Yes, this is the screen. The screen was 60, so everything on this line is 60. Is it supposed to be 60? Well, we could do a quick estimate of the drain on that line, how much current's on that line, and we could just say, just off the craziness, 5, 10, 15, 20 milliamps flowing through that resistor. So you have 20 milliamps against 2700K is the same as 20 times 2.7, 50. What the heck did I just calculate? I don't know what I calculated there. 50 is the number that came up. 50 milliamps. Now, for God's sakes, what have I done? Try that again. Okay, so I'm thinking there's 5 milliamps in each of these tubes for 20 milliamps. 20 milliamps flowing through a 2.7 K resistor is the same as 20 times 2.7. It's 50. $50 volts falling on that. That's what I'm after. 50 volts falling on that. It would leave you 60. It doesn't seem right. Probably those tube currents aren't nearly as high as what I did that with. If they were half as much, then the voltage drop would be 25. Then you would have about 90 on these. And 90 is much more typical. Let's turn the set back on and measure some more voltages here. Not with this. With this. A 150 volt scale over there on the meter. Checking the B plus level first. Ooh, careful there, Tim. Don't short those guys out. 130. All there. On the plate of the output tube. It's all there. It's the question about what's going on here. Okay, so there's a 130. And then right beside it, that's got the resistor. So that's probably the input side of this resistor. That doesn't make sense because that should be the output side according to what I thought before. And right beside it, it's another terminal running at 70. Let's verify what terminals those are. So, looking in there, handy, I put that capacitor right over top of it. So there's the key. I see the key. Okay. Pin 1, 2, so 3 is 130 and 4 is 60. 3 is 130, not that tube, yeah, output tube. 3 is 130, that's right. And 4 is the screen is 60, the other side of this resistor. 60 is starting to sound right. Nowhere do they tell me what voltages to expect out there, but 60 is. Sounds right in one sense, but 60 is crazy low. And none of these tubes are made to go on 60. Sometimes the detector tube is running with a very low plate voltage. What am I going to do here? Why would it be low? I've replaced all the capacitors, so there shouldn't be any extraordinary draw. Is there another resistor? Oh, there's this 4.7K up here. How can you possibly get the same reading on either side of this resistor? This would knock the life out of what's left of the B plus out here, I would think. There's a very, very tiny current flowing through this tube. Hey, let's double check that. What kind of current does flow through these tubes? We'll pick that first one, 12 SK7, SJ12. It's going to say, look at the 6. So we'll look at a 6 SK because they operate the same. 6 SK, plate voltage, plate dissipation, plate voltage, plate resistance, come on, plate current, there it is. 13 milliamps, 9.2 milliamps. So around 10 milliamps. The rest are going to be similar, I would think. 12 BE6. 6 BE6. 6 BE6. BE6. 6 BE6. Okay, typical operation, plate voltage, plate resistance, plate current. Oh, 3 milliamps. So probably my 5 milliamps a tube is a pretty good estimate. 5 milliamps a tube leads to 50 volts dropping on this resistor, and that's what we're measuring. Leads to extremely low B plus in the front end tubes. Lower than what I would think is correct, but that's just what I think. I don't know for sure. I think what we'll do at this point is, now I'm well aware of the situation with the voltage in the radio. So we'll carry on. There are other problems that need to be resolved. Just that howling we heard says to me I've hooked up a capacitor wrong. That's what that says. Let's try as I may to not do that. And how come every time we have the radio upside down it sounds like that? Let's do this. The last thing we'll do. Because my objective was to do an alignment, and I think I'm running out of time. The radio is currently operating. Take this off so I can turn the radio over. And let's turn the volume up a little bit here. So is all that? Is that from this? That I'm talking about was the motorboating, which doesn't seem to be there now. Wow, this variation in the operation is really... oh, it's my hands. We need to put the antenna on. We're going to really find out if this radio works. I have to hook up the antenna. Okay, so I'm going to set that up with just some clip leads, as inappropriate as that might be. I shouldn't have stopped the video there. I just made work for myself here unnecessarily. So this lead goes to here. Now the other lead goes into the radio. Not sure where it's going. Be sure. Can I get sure? Maybe I can get sure. The antenna goes to the chassis. Probably connecting inside the chassis somehow. We're going to cheat and use that. And now, which of these terminals it's the right one. I can see where the wire broke off on that one. That's it. There, it's got a radio. It's got an antenna. It sounds a lot more like a radio now, doesn't it? Let us tune. This is a really ill radio. It's a sick puppy. The radio's tuned to somewhere in the middle of the band. So let's go over here somewhere in the middle of the band. And around here. Okay, so I'm going to tune the radio lower, get it more in the range of my signal generator. Signal generator is just energizing this coil, and this coil is just laying on top of the antenna. That's going to be plenty of injection here. So now we're down 700. There it is. How do you like that? Your radio's actually receiving something. So why not receive a nice radio station? This is not the strongest signal, and I'm just putting it in that way. This thing should be able to receive a radio. Oh, maybe the antenna wasn't aimed in the right direction, my earlier test. And it just fooled me. So what we'll do is we'll force the radio to a strong station, 590. By that I mean we'll use the signal generator to make sure it's on 590. That's 590. You can hear a little heterodyne in there. I wonder if that's the station. We'll take the signal generator out of the picture. You'll hear some motor boating in the radio. Now, this is an unhappy radio. He's very, very unhappy. But he's picking up the station. I hear it. It's in there below all that malarkey. So that's really a bad test at this point. I would expect this radio to be actually producing pretty good radio now, and it's not. So something more is going on here. And gee, would an alignment somehow help that? Interesting question. We can give it a quick shot at answering that. I'm going to fire in the IF. See, for all I know, somebody's reached in here and monkeyed around. And who knows? So I'm just going to fire the IF signal on here, 455, like that, and we'll see if it comes out of the speaker. There it is. Take off the antenna to quiet the radio down. Just realized the whole time I was testing the radio, I had the radio upside down, and I hadn't turned my head upside down. I was hooking up to the totally wrong terminal on this capacitor. Now that I'm looking at it, totally wrong terminal during that other testing. Live and learn. That's how it goes with this, right? Every step of the way, you learn a little more, often because you made a boo-boo. So what's this proving? Not proving an awful lot. Can I quiet this radio right down to nothing? Now the sound you're hearing, I think, is the signal generator. Yeah. So here, that should just be a nice. You should you just hear that tone get louder and quieter. You shouldn't hear all this other. Something wrong. No use doing an alignment until this is sorted out. That's what I think. And sorting this out, if it's my mistake, it's going to take a long time. That's where we're at now. It's a little better than it was, but it's not where it should be. So, well, thanks a lot for watching today's efforts, and tomorrow we'll pursue this howl and try to get the radio into a state where I can align it, and then we can see what it really amounts to, because it's not there now.